Thank you, my friend, to invite me in the city of Landstroman for the jubilee of Gulstrand and Presbymania. I want to present you today PresbyCor Allegretto Wavelight treatment with asphericity, our software, and with a result in 75 patients. And our accommodation approach, where we see that we can speak with other colleagues about that. I remind you that I've been operated 7 years ago by Jérôme Mondel with this software, and I want to say what we think today. So, asphericity is very important. It's very important because it's not dielectric power. Asphericity is defined as a curvature of a curve. It describes the shape of the cornea, flat or oblate, and not power, not dielectric power. So you know that the average value of corneal asphericity is -0 to 6. Asphericity is a specific treatment. Ablation depth is greater in the median periphery, and you keep the same shape of the cornea. It's important to know that because you will see that we have very few keratometric change, and we have only the shape of the cornea which change with asphericity treatment. If you increase negative corneal asphericity, as you can see here, you decrease the positive spherical aberration, as you can see here, and we see you have a prolapsed cornea after. So increase negative corneal asphericity, decrease spherical aberration, increase depth field, and more prolapsed cornea. We are speaking today about depth field. A reminder about the average value of the depth field reported by 30 study is evaluated to 0.30 diopters. Our study shows that depth field can be increased at 1.5 diopters without secondary effect, but not sufficient to read. Professor Malcaz in Toulouse shows that here that we can go only 0.60 diopters. If I understand you today, panel, I see you speak about 0.50 diopters, but normally it's not sufficient to read. So depth field can increase with spherical aberration, of course, but it's not sufficient because about meiosis, about a lot of things, it's not sufficient to give a good reading vision. What we know about accommodation, we notice that with I2C, we use frequently I2C. I2C is aberrometer for internal and corneal aberration. With our patient during accommodation in a young patient, we have a compensation between internal and corneal spherical aberration, as you can see here. So it's important to know what happened in a young patient. What are the principles of accommodation? We know the retinal blur, we know the distance of the target, the dissimilar image, and all that thing leads to accommodation with meiosis and convergence. But until now, we don't speak a lot about compensation of internal and corneal aberration. It's very important to increase the visual quality. So, what is the principle of our treatment? According to our Roser and Presbyopia, we increase in corneal spherical aberration, is tied to age, and leaves a significant retinal blur, as you can see here. Making the cornea more prolate. Making the cornea more prolate, we induce a decrease in spherical aberration with the asphericity, less retinal blur, and more depth field. And with this kind of image, we can normally with the brain, we receive a better image, we can normally reduce a better accommodation. In another way, in some flow movie, you can see here retinal blur, excessive spherical aberration. The retinal image is too blurred, and the accommodation is no good or inhibited. When you decrease in positive spherical aberration, the retinal image is less blurred and the accommodation is again possible. So I speak a little about our software. Asphericity is very important because what is the first track when programming an aspherical versus a standard treatment in a hyperopic patient? For treatment of +2 standard ablation, depth is 32 micron. With a Q factor of -0.80, ablation depth is only 12.8. So aspherical treatment induces an intercorrection shift of 40% in hyperopic patient. And it's why for this kind of patient we need a correction factor of 120. We must be added to a target treatment sphere of +2 with a Q value of 0.8 to get an ablation depth identical to a standard treatment. It's all the calculation we have to do for this software. And the correction shift depends also on curve keratometry, because if you have a flat keratometry, you have 47 micron, with a step keratometry 42 micron, so it's imperative to take account keratometry to optimize precision in the result. And the same when we operate patients too, we have to know the pre-asphericity. Is a patient oblate or prolate, where it induces another correction shift corresponding to 1 diopter, and we need to know that. Here a diagram will show that we get another correction effect when the cornea is oblate and when the cornea is a step. And you can see it's important, the difference between 42 or 75%. And it's the same with the myopic patient. When the cornea is oblate or step, we have an overcorrection effect, and we have to get a compensation. Another way with the Allegretto is with secant defocus. Secant defocus is a second order aberration which corresponds to the spherical component of ametropia. And for a sphere of +2, the aberration rate is 312, for example, and we use the Zenit coefficient to compensate for over or under correction induced by the FCAT treatment. So you can treat with asphericity, you can treat the same value, and you have the most of time to subtract for the aspherical treatment a corrective factor to write the same value. So we use for myopic treatment the FCAT. So before surgery, what are the criteria for treating presbyopia? You know, maybe this diapositive, but before surgery in presbyLASIK, we use pentacam to know the corneal asphericity, we use ultrasonic to know the internal and corneal aberration, and we use the OCAS. The OCAS can give us the residual accommodation, and it's important to know that, and the cataract index if we want to get surgery for cataract. Here is the software. In our software, we have to put for myopia, the ametropia, astigmatism, presbyopia, keratometry, pachymetry, and residual accommodation, and the acuity for myopia and for hypermetropia or emetropia, and that gives you what you have to enter in the laser. So the study conducted in 75 patients, I remind you, is bilateral surgery without monovision or micromonovision, very less micromonovision. Wavelight Allegretto 500, target asphericity is -0.8 or -1, and calculated with the PresbyCor software. What we get, of course, we get most of time corneal asphericity, increase of corneal asphericity, like -0.80. But the most interesting is that diagram. If we, after asphericity, increase asphericity, we decrease in corneal spherical aberration. And you can see we decrease in corneal spherical aberration. It's normal, it's what we want. But in the same time, without touching crystalline length, we have a change in internal negative spherical aberration. And you can see at the beginning the negative spherical aberration or crystalline negative was here, and now it's here. It changed without touching crystalline lens. So we have again corneal and internal spherical compensation. It is a proof of the reactivation of accommodation. We think so. As my colleague says this matter, I think we can get a new reactivation of the accommodation. With the other machine, with the other technique, with the OCAS, the result on 75% shows the increase in accommodation by 2 diopters. We start at 0.75 and we finish at 2 to 5 diopters for the most of the patients. So accommodation increased with time. As in my own case, it was 6 or 7 years ago when we improved visual quality. As you can see, 10 months after, it was from +1 diopter, 3 diopters was calculated with the OCAS. 26 months after, we have the same result with 3 diopters, and now 6 or 7 years after, I have the same accommodation. The visual quality improved with the time, of course, and the refraction post-op at 12 months is 0.08 diopters, no myopia for the new reason. Klaus Fenbaum speak this morning about PresbyCor, is software like us, but I think PresbyCor play more on a dioptric power, and we play more on aspheric treatment. And I think it's different because we have no problem in distant vision with the aspheric treatment. Asphericity induced very few keratometric modification in imetropic or slight hyperopia. I was imetrope 7 years ago, and I'm imetrope with a little hyperopia now, but with a good distance, with a good near vision. And as you can see, we have very few modification of keratometry. We have good result in visual acuity, near vision or distant vision because of asphericity. And to conclude, PresbyCor software is a new software, but I have experience of some years. It's a bilateral hyperpolarization without monovision. As you can see, we have a compensation for the refractive shift is obtained by modifying the stromal ablation depth in imetropic and hyperopic patient, and we use the CCAT in myopic patient, taking into account presbyopia, keratometry, Q factor, and residual accommodation. Residual accommodation is, I can speak after about that. Hyperpolarizity does not have distant vision in long term, even in young imetropic presbyopic patient. And it's very important to start with a good binocular and stereoscopic vision because all is very tight. The brain reduces our residual accommodative capacity, which play an essential role in presbyopia by providing a rail